Before we get started, I want to give huge shout outs to community partners Epilepsy Foundation of America and the Danny Did Foundation. Also, big thanks to Neurelis and SK Life Science. Thanks so much, y'all, for believing in this podcast and making conversations like this possible. Okay, here we go. Hey guys, welcome to this very special episode of What the F. I am at the University of Wisconsin-Madison Medical Center, and I am so excited to talk to this researcher and the person behind the research. We are going to dive all into it. It's so exciting, and honestly, I feel like this is one of the most important episodes I have ever done. So without further ado, I'd like to introduce my two guests today. We have Dr. Avtar Roopra, who is a professor at the University of Wisconsin-Madison, leading neuroscience researcher, has his own Dr. Roopra lab, kind of a big deal here. And then, speaking of big deals, we've got Morgan Giroux joining us. She is the founder of Lily's Fund, which is a beautiful nonprofit that supports epilepsy research at the University of Wisconsin-Madison and, helped kickstart Dr. Roopra's research from it. So thank you guys so much for being here. It's so awesome to have you.
Pleasure.
So it's a real pleasure.
Okay, so before we, I just want to start from the beginning as like what this research is. And so, Dr. Roopra, when you explain it, talk to me like I'm 5, because I am 5 when it comes to understanding this stuff. So, but if you could just explain like why this epilepsy research is what it is and how it works to a 5-year-old.
Okay, well, epilepsy is a disease. It afflicts about 18 million people around the world, and it's characterized by uncontrollable seizures, where the person will have huge amounts of brain activity. They can lose consciousness for sometimes seconds, sometimes hours, and it can be lethal. And there are no cures. It's devastating. And our job has become to find a way to get novel treatments which are better than what's currently available and which helps about the 30% of patients who do not respond to current drugs. That's what our goal is. That's what we've been doing. And our latest finding, which was published recently, really highlights and debuts a new class of drug which seems to shut down seizures well into disease, unlike current drugs which only somewhat control seizure activity. So we're excited about that. And the other important thing is people with epilepsy often suffer cognitive problems, and current drugs tend to just exacerbate those. They make them worse, or at the very least not fix those cognitive problems. And what we found is that our agent that we've come up with actually restores cognition and memory in animal models of disease, of epilepsy, which we're very excited about.
So it controls seizures and then also stops the cognitive issues.
That's right. That's right. In animal models, in mice.
Right. Now, but this is a drug that's already FDA approved, correct?
That's right. It's been around for decades, and it's been used for controlling things like rheumatoid arthritis, psoriasis, and other autoimmune diseases. And a very clever person in the lab, Dr. Olivia Hoffman, who can't be here today, was the person who really pinpointed this drug after analyzing all of our data and said, this is the drug that should work. It's already in the clinic. It's available for humans. Let's try it. And actually, I wasn't convinced to begin with. And it took Olivia's belligerence and insight that I didn't have to go ahead and try the experiments. And that's how we found that this drug, which is already in the clinic for other diseases, had this profound effect on suppressing seizures and restoring cognition in our rather drastic models of animal epilepsy.
So tell me a little bit more about like the stopping of the seizures, because what I read, and I could have read this wrong, again, this is not my field, but that not only that it stopped seizures, but after taking the medication, it also stopped the seizures?
The holy grail of epilepsy research for centuries, because don't forget, this disease has been characterized since the time of Hippocrates, right, 2,000 years, has been to find a treatment which you can give briefly, then withdraw, and leave the patient free of seizures and with normal brain function. It's a bit like taking an antibiotic. If you have an infection, you take the antibiotic for a short period, the infection disappears, and then you can stop taking the drug, and you're free of the infection for life, right? So that's been the holy grail for epilepsy research. And what we found with this drug is we can give it to our animals for 2 weeks. By the third day or so of treatment, the animals are seizure-free, pretty much. And when we withdraw the drug 2 weeks later, for months afterwards, the animals remain seizure-free and their brain function remains restored. And that's called disease modification. It's been something that we've been looking for a very long time. And we're very, 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 very excited about it. It keeps me awake at night, and I keep wondering when we're going to find that there's a flaw in what we've done. And we had collaborators over at Tufts University in Boston. We asked her to repeat our results because it's not that I didn't trust them, I just couldn't believe them. And we gave her the drug, and Dr. Jamie Maguire, did the experiments, and we didn't hear back. And I thought, oh, there's something wrong. Well, it turns out we didn't hear back because she didn't believe the results and got her postdoc to redo the entire experiment. And it now works in 3 different labs across the country using 3 different animal models. It's the most exciting thing I've ever been part of in my entire life.
I went from, I'm about to cry because just hearing that you can take something and then seizures go away. As someone, I'm getting very emotional here, someone who experiences seizures really frequently, and also cognitive issues as a result of the seizure, as a result of medication. It really is, it's just something I never thought could happen. Like you and the much smarter people look, and the fact that it's happened 3 times now. I mean, that is, oh, wow.
I know, it gives me chills too. You're going to make me cry as well.
Oh dear. Well, just to be clear, these are still early days. These are animal experiments. So we are extremely excited, but we have to remain cautious because the biggest threat to science is our own optimism. And we've got to be careful about that. We can't let our excitement lead us astray. And so as excited as I am, and it is the most exciting thing I've ever done in science, we have to be cautious. And so the next phase of this project will be to move this to human clinical trials and see if the results we see in animals translate to humans. And even if they're just half as good, it'll be, for me, a time when I can look back and say, yeah, I was allowed to be part of this project, and I was surrounded by amazing people, and I can now retire. So.
That would be a great thing to retire on. Yes. Okay, Anne, I wanted to talk to you about kind of, I know you two are very good friends at this point, but also that started so long ago. With the just because Lily's Fund started so long ago, and how did you start putting the Lily's Fund research money into Dr. Avtar's, Avtar's/Dr. Roopra's?
Yeah. So many years ago, when our daughter Lily was young, still a child, and it suffers from seizures, we just read in a local paper about an exciting project happening at UW. And it turned out that my husband David's office was literally right across the street from the lab where the research was happening. And so we're like, wow, this is pretty cool that this is happening here. So we asked to meet with them. We met with Avtar and a few others that were here at the UW at the time. And we went home and we're like, okay, let's invest in this. So we made a personal donation to the research, and that's where it kind of stopped after 6 months, a year. And then we're like, let's take this bigger. So we decided to have a fundraiser, and we really wanted to have the fundraiser be fun. We wanted we call it the joyful pursuit of a cure, and that's what we really wanted. Especially,
I do love that.
Yeah, especially in honor of Lily, who is joyful and fun. So we decided to create Lily's Luau, and for 10 years we hosted this giant luau party on university grounds and raised a shit ton of money.
And it was in the middle of winter. It was a luau.
Yeah, in January.
Oh, that's when you need a luau,
Right?
though.
Of
That makes
course.
the most sense.
Coconut bras, straw skirts in the middle of January.
And what was so fun about it is every year it just grew, it just mushroomed. I mean, I think we started out with 100, 150 people year one, and we got to 1,000 people at the end. And we had researchers in coconut bras, including this one, and grass skirts. I mean, it was a ton of fun. It was not sad and maudlin. It was fun. And what we did with the money, we wanted to be very thoughtful about what our mission was, because we are an all-volunteer group. We don't have any staff, so we wanted to be very focused about where the money went. So we wanted to support research at UW, and we decided to create these grants called Grace Grants, and they're named after another young woman in the Madison-Verona area who has epilepsy. And every year we give away $100,000 to, we have a call for applications, and it can come from any department at UW. It can be, radiology, neurology, neuroscience, psychology. And then we have a group of academics rate the grants. We don't choose them. We don't understand them.
I can relate.
Yeah, I know. I knew you could. I'm 5'2".
I'm 5.5.
Oh, hell no. You are not older than us. No way. And then so we do this every year now, and even though we don't have the luau anymore, we're still raising money. A lot of outside groups raise money for us. We're doing will and estate planning with money. We're doing donations. We're still moving forward and funding research. We're just not having the giant party.
That's
So,
awesome, though.
yeah.
I mean, that's so cool.
It's been really fun to watch, and I think your original question, which I guess I haven't answered yet, is how did we fund some of Avtar's research? And he was one of the first researchers, I think, to get the grant. We've always kind of believed that we're the seed money, and $100,000 in research money isn't a ton, but it is enough to start a research grant that you might not be able to do otherwise. And I know you've talked about this a little bit. NIH isn't going to give you money for something that doesn't have some background or, proof of life or something ahead of it. They want really established data. So our grants start that. We give Avtar $100,000 to start that, getting that data, creating that proof that there is something behind this. Then they go on and they can apply to other organizations like Cure Epilepsy, NIH, and other bigger funders, and it just keeps growing.
Okay,
So-
that's so beautiful. So that you guys are we're gonna give you I don't know, I can't find anything to compare it to except a startup fund almost.
It's a seed fund.
Yeah.
It's a primer for the pump. So the way research works is we have an idea at the very basic level. We have an idea. We think it might have legs, but we can't just go to a big funding agency like NIH at the federal level and say, we've got this fancy idea. Can you give us some money? They're not going to do that, because just like with Lily's fund, NIH doesn't choose the grants. They get scientists from around the country to review the application. And the reviewers want to know, does this grant have any data behind it? Does it have substance behind it? They don't want to just do complete pie-in-the-sky stuff. They want to know that there's going to be return in their investment. And so you need to prime the pump. And that's where Lily's fund comes in, because we had this idea of using this mathematical model we built, which would predict what targets to go for epilepsy, but we didn't know what the targets were. We didn't have the data. We just had this mathematical model. And that's where Lily's fund comes in. They took a chance. We used their money to actually develop the models, and we came up with a target. And then with that, we then went to NIH and said, okay, here's the seed of an idea, and there's some data behind it. And then they gave us a smaller grant called an R21 to pursue this further, to see how far it would go. And it went quite far. And from that, we then took that data and applied again for a much larger 5-year grant. And that required us to convince reviewers from around the country, scientists from around the country, that this was a good idea. And luckily for us, they thought it was a good idea. And that pushed us forward. And with that, That was a 5-year grant. With that, we then tried again because we needed more time, needed more funds to push this further. The second 5-year grant came, and at the end of that came this finding and this manuscript. So the system worked perfectly. We had an idea, somebody to prime the pump, that was Lily's fund. From that, we went to NIH. They gave us their seed money. From that, we expanded it out to 2 5-year grants. And at the end of that, we have an agent with a first-in-class property of being able to stop seizures once the drug is given and then taken away. And now we're ready to push this to clinical trials. That's where we are now.
Wow. I mean, it's just so amazing because like all I keep hearing over and over is how good this research is.
I'm slightly biased.
Well, but you're just sharing the facts of the story and that, you know, a lot of other academics had to agree to make this happen.
Absolutely.
So, and there was one other, and I read an article that also said something about this affecting breast cancer somehow as well, your research?
So our lab does cancer research as well as epilepsy research.
Okay.
And there's a tail in that as well. But these models that we developed, the tools, the computational tools and the pipelines we use for data analysis, they were originally all developed using breast cancer data because there's a lot more breast cancer data available than epilepsy data was available, the kind that we needed. And so the offshoot of all this, the side product of all this work, was that we were able to contribute to the breast cancer field as well. And so there was this synergy and this kind of cross-fertilization of these fields. And what we learned from breast cancer, we moved to epilepsy and vice versa. And that's what really propelled us forward. And in fact, a number of reviewers for our grants commented that one aspect of novelty was how we were able to take information from a whole different field and leverage it to find treatments for epilepsy. And just to be clear, none of this would have been possible if it wasn't for the seed money from Lily's fund.
Oh, I believe it. That makes complete sense now that I, understand how this works. But speaking of, you did mention NIH funding, and it's kind of this, I feel like as for a general population like myself, a little bit of a gray area as to how this is directly affecting research labs like yours. And you keep saying like we're ready for clinical trials. So where are things like right now for your research, for the lab, for clinical trials?
So under normal circumstances, given our findings, given the publication, given the attention it's received, we would have applied for another bolus of 5-year funding, which would have included aspects of a clinical trial, the first steps. And under normal circumstances, we are pretty certain we would have got those funds. But because of a whole cascade of delays and cuts and termination notices at NIH, what should have been a slam dunk was stalled out. And we got pushed to the back of the queue of grant applications. We've had to start from scratch again. We'll see where this leads, but it's had a catastrophic effect, the impact of NIH cuts, because one thing you may gather from what we just discussed was this whole project started in about 2010. It takes that long. And over that time, you need continuous transfer of knowledge from one generation of scientists in the lab to the other. Right? I sit in the lab all day, but I don't do the experiments. I do everything but. And there are really smart people who come in and do the work, and they hand off knowledge from one generation to the next. With these funding cuts, that transfer of knowledge, that relay game, got stopped. And there's already layoffs happening. There are people having to leave my lab who are going to take that generational knowledge with them. And they're not going to sit around waiting for things to get back to normal. They're going to get other jobs. They'll go on with their lives. If things do return to normal, if we do get funding again, we will be set back years because we're going to have to rediscover that generational knowledge. It's not like you write down everything and somebody new in the lab can just pick up your lab book, read what you've done and carry on. It doesn't work that way. There's a whole bunch of intangibles that have to be transferred person to person, much like doctors when they change shift in the middle of the night. There has to be a handoff period. Doctors don't come in and just read the notes of a patient and start. They have a handoff.
Well, sometimes they do. But.
Sometimes they do. I think the biggest example at the moment is many of your viewers and listeners may have heard about the trouble that NASA is having trying to send humans back to the moon, right? The reason why they're having trouble, even though Americans did this many, many times from 69 onwards, is because when that program was cut by Nixon, a lot of those engineers who were working on the Saturn V moon rocket, which took humans to the moon over and over again, they left. The blueprints disappear. There's no handoff of generational knowledge. So now, now in the 2000s, when we want to go back to the moon again, those engineers aren't here. That generational knowledge was lost. So we're having to rediscover how to build those rockets. And there's failure after failure after failure, even though we used to do this all the time. And that's kind of where we are at the moment. With this slamming on the brake pedal of research, which is what's happening now, even if that foot is released off the brake and the accelerator's gunned down, that car's going to stall out because the generational knowledge is now missing. We're going to have to relearn how to do all this stuff. It's not an exaggeration. There is generational knowledge being lost, not just in my lab, but in all labs. Mm-hmm. The US was the greatest driver of biomedical research the world has ever seen. And now scientists are trying to find jobs in Europe and elsewhere. There's a brain drain going on. And instead of the best scientists from around the world coming here, the best scientists in the world are now thinking of going elsewhere. This is an unmitigated disaster.
Yeah, I mean, it's so huge. It's so huge, and I really appreciate the comparison to NASA to explain that. So like as like in your lab right now, are things just kind of at a halt completely?
It's not a complete halt, but we're in a holding pattern. Okay. So we had all these resources, mouse colonies, for example, other reagents, which had to be kept going. That costs money. And now with the constriction in funds, we've had to shut so much of that down. So even if the funds now arrive, it's going to take a year or so, 2 years, to rebuild those resources before we can even start the experiments again. So we are in a holding pattern. The kind of experiments we're doing are the things that are cheaper, but not as impactful. The experiments we're doing aren't going to be perfect experiments, which is what we insisted on all the time, which is how we got where we are. And now we're going to have to trim down and cut corners. And so the data we get will be there, but it won't be as robust, which means the structure you build on top of that data is not going to be as tall. It's not going to be as robust. That's what we're worried about. So to answer your question, we're in a holding pattern, doing the best we can with dwindling resources. It's not about becoming more efficient. We were already as lean as you could possibly be, right? Science isn't flush. It's not like in the movies. CEOs don't drive around in fancy cars and have helicopters. That's not how labs work. We bike to work. Our students are paid poorly. The postdocs don't have friends. They don't sleep. It's
Don't have friends.
There's camaraderie. You've heard of this. You've heard of the struggling artist. Well, actually, the reality is there's struggling scientists. We all do, right? So it was always lean. There was never any fat to trim. So this idea that you can cut NIH funding and things will just get better and more efficient, it's a lie. Mm-hmm. It's a lie. There was no fat to trim.
Yeah. Oh my gosh. Well, all those postdoc people, if you need a friend.
I hope Dr. Hoffman's not listening. She has many, many, many friends.
Okay, so is there any way we can, I know this is a time where there's a lot of people who, like myself, are like, what can we do? How can we keep this going? Especially something as impactful as this, something that has been peer-reviewed several times, even by, I remember you saying, Dr. Dan Lowenstein, giving you quite the review for it, right. Who's one of the leading neurologists in the country. In the world, thank you. Sorry about that, Dr. Lowenstein. I meant world. So what can we do, to get any possible funding for you, or can we donate to Lily's fund, or what? I mean, I know like everyone probably can only afford to donate $10 right now, but like, does that make a difference?
Well, I think there's two things you can do. We can't, Lily's Fund, unless we find a giant billion-dollar donor, can't make up for NIH funding. NIH funding is huge. I don't think any nonprofit could fund at that level. So that's kind of out of the realm. But that's not to say we can't keep things going and beef up some of the research Avtar is doing, as well as other epilepsy research going on here or wherever you choose to donate. So don't disregard donating and helping wherever you choose to help, whether it's Lily's Fund or Cure or Epilepsy Foundation. I mean, they're all good places to put your money. For us, that is our sole purpose, is to find a cure for epilepsy. And so that's where the money's going to go. The other thing I think is to call your legislators, because this NIH cuts are in the budget, and the budget is being talked about now. So if you've ever heard of the app 5 Calls, it's super easy. All you do is put in your zip code and it comes up with all your legislators right there. Then you can kind of scroll down and pick a topic. And one of the topics is, I think, science or healthcare. It doesn't really matter. You just pick that. It writes out a script for you, and you can do that script if that's what you're comfortable with, or you can throw the script away and say, God damn it, my kid has epilepsy or cancer or Alzheimer's or Parkinson's, and this is crazy. NIH funding is critical to scientific research. We have to have this, and then it automatically sends it out to all your people that need to hear it. Do it every day. It takes under 5 minutes.
Yes, it does. I've done
Under
it.
5 minutes, and do it every day.
I'm going to drop the link in the episode description. So if anyone listening, wants to do it right now, it literally takes less than 5 minutes. You enter your zip code, and there you go, and you've got it.
Yeah. I mean, there's no way that we can have private companies or anybody else make up this scientific research funding. It's just not possible. Plus, NIH is non-biased in how they give out their funding. I mean, you just heard it. They get researchers from around the country to review these grants and decide very competitively who gets funding. That's not how it's going to work in the private world. It's going to be based on influence, money, all of that. You want this to be non-biased. I mean, you want all the diseases and all the scientific stuff to be spread around into where it can be used best.
I have to underscore all of that. And one thing that needs to be got across is just how NIH works. I have reviewed for NIH. I did so for many, many years. And I can tell you, of all the people I interact with at NIH, there's not a single person who was not pulling their weight. There wasn't a single person who wasn't completely committed to the cause. There was no dead weight at NIH. The scientific review is the most rigorous in the world. I've reviewed for grants around the world. And I can tell you that the way NIH works is the gold standard. Everybody around the world says, we wish we could do things that way. Okay? It's not a handful of people in DC who handpick a grant based on some personal bias or grievance. Scientists from around the world get together in a room. There'll be about 50 of us. We each review 10 grants. Each grant takes about 3 days to review. Okay, so that's a lot of time that we commit, our own time. It's done in the evenings. It's done. We're not paid to do that, right? So it's a civil service that we provide as scientists. They all get in the room. They then talk about the science that they've read, the grants that they've reviewed, to the entire panel of 50 scientists, who then vote and rank those grants. And that happens for every committee. And there are thousands of committees because there are thousands of grants that need to be reviewed. And only the top few % are ever funded. It's not glib. It's not biased. It is rigorous. It's the gold standard. And so that has to be protected. This is not something that can be handed down to the state level. It has to be done centrally so that you can get the brains of the entire country involved rather than just the brains of an entire state. That has to be got across. There is no waste to be trimmed at NIH.
Wow. Again, my brain is like, I just didn't know any of this, and I appreciate you sharing it. And things, I believe in one of our conversations, though, you had mentioned there was an application for a grant that you had put out recently. Right? And it got a good score, but this is just me being 5 and like, I don't got a good score.
So going back to this idea of the stalling and the cutting and the missteps. So this is a grant application for the next 5 years, which we put in towards the end of last year, and it got a good score, not a great score, because that's how it works. You have a good score, you then put it back in, having addressed the reviewers' comments, then you get a better score, and you just do this until finally you convince enough people that it's worth doing. And it would have, under normal circumstances, got bridge funding to carry us over until it was re-reviewed. That was all cut. And so we then had to start from scratch and go back to the beginning at the back of the queue and start again. And that delay is enough that I had to lay off people in the lab. Because, like I said before, we don't have a buffer. There is no reserve. There's no fat to trim. So if you break this line of funding, things go south very, very quickly and very, very immediately. And so I have a lab manager who's worked with me for nearly a quarter of a century. That's generational knowledge. He's going to have to be let go. And because neither the department nor I can afford to keep this guy anymore while we wait for NIH to kick back in and get the money that's required, because we don't have reserves.
So then I guess this brings me back to, donating to Lily's fund. And if larger donations than $10 would help bridge some of this while you're in this holding pattern. Not that it could ever solve the problem, not that to your point, private funding couldn't solve it, but if there's any way we could raise, a gigabbillion dollars. Well, if we had that, then
billion dollars,
then we'd be fine. But if we could, this is where my ignorance is showing too. But if we were able to get magic number to me is $250K, just to help bridge some of the things, so we're not losing the generational.
Right.
Does that? Was that just me being optimistic?
I don't. Well, yes, optimistic, but in a good, rational, optimistic way.
Okay.
I mean, you like that? Okay. If we can raise $250,000, I'll use your number, then we can use that money to fund to help bridge until NIH kicks in again. Can we stop like you were saying, the
hemorrhaging?
The hemorrhaging, we can stop it and wait.
Right.
It can't make up for it, but it can prevent a lot of loss. Would you say that's a correct?
I think that's exactly right. So, but think of this, right? Imagine if we were here and NIH wasn't slashed the way it is. All of a sudden, we'd be saying, well, with 250,000, what new ideas could we seed, right? What new approaches could we come up with? So what every lab here and around the country is now doing is diverting resources to go into a holding pattern, to go into a stress mode, just to try to ride this out. The problem is we don't know how long this period is going to last, right? So you can only stay in this holding pattern for so long. That's the issue here. So to use your number, 250,000, that would stop the bleeding. We can keep the brains in the lab, literally. But for how long, we don't know. The most important thing is that these cuts to NIH be reversed and people accept that NIH isn't some cabal of elites picking and choosing. It is a powerful source of healing and cures for diseases around the world. And it needs to be funded at its current rate, which is not egregious. It's as trim as it can possibly be.
And let's just go back to what we first started talking about, the why. The why is you and my daughter Lily and the thousands, millions of people who are going to hear this podcast, billions of people who are going to hear this podcast.
I think it's good jabillion.
Good jabillion?
Yeah.
Good jabillion. who either have epilepsy or know someone with epilepsy. And here you do have some research that has this potential to stop, to reverse. Again, we can't say for sure, but it has the potential. And it's the first thing that's had the potential that I've read about. I don't know about you. You know more than me. And it's sitting right there, right? Ready to be downloaded to human trials, just sitting there. And we can't do it. And I don't know about you, but that really makes me mad.
Yeah.
Really makes me mad.
I'm like tearing up again because it's just so tragic.
It's
needless.
an FDA approved drug.
Right, it's already out there.
So if this were not an FDA approved drug, it'd be like, okay, well, we're still 10 years away then because it has to go through all that. But this is. I mean, literally sitting there waiting to be plucked.
That's right.
Yeah.
And it's so frustrating to me.
Yeah. It keeps me awake all night, every night. Same with every member of the lab. Our collaborators around the country, around the world. We have a collaboration in France. It's right there, as Anne says. It should be a slam dunk. But for needless reasons, there's been this barrier put up under the pretense that somehow NIH is incredibly wasteful and it needs to be cut. And that's the tragedy of it all. If the people making those decisions could just sit down for 5 minutes and have a conversation, they would realize that the immense amount of dedicated effort put into these projects by people in the labs around the country, if not around the world, it's all going to go to waste for what would account as a rounding error in the budget, right? The kind of money we're talking about for NIH cuts it's a rounding error in the federal budget. So it's just sad.
Yeah. I mean, it's so strange just because we started this episode being like, oh my gosh,
I know,
we've got this drug that could potentially do this, and it's already FDA approved, and we've seen it 3 times, and now we're like,
But okay, so we always want to give people something to do, right? And you're optimistic, so I'm going to join you in this.
Love it.
2 things. You donate. You can go to liliesfund.org to donate. You call your legislators. And you can do this in any way you want. You can use the 5 Calls app. If you are someone out there with influence, really call them. I mean, especially if you're influenced and you're affected by epilepsy, you get on that phone and you say, what the hell, why are these NIH cuts happening? This needs to come out of that budget. So I think people need to do something.
Agreed.
Everybody needs to do something.
People want to. Yeah. I think people want to. And so both those links to Lily's Fund as well as to the I can never remember.
5 Calls.
5 Calls will be dropped in the episode description.
Great.
And pushed out because I think people are feeling a little bit like hands tied behind your back right now.
And from the scientific side, there's so much room for optimism. So we have this drug. It has these seemingly amazing properties, but there are other drugs like it, similar to it. There are other compounds that people can now develop based on this structure. And we have collaborators at Emory University, at Tufts in Boston, in Marseille in France. We've got friends in New York, at NYU, and at UCLA, and they're all excited by this, and they're going to try this out in their hands. And some of those people, some of those researchers, they are working on traumatic brain injury, the kind of injuries that soldiers get, vets get for blast injuries. And everything about this research tells us that those are the people who are going to be most benefited by this kind of drug, because so many of those soldiers come home not knowing that they've got epilepsy. And then they'll have a seizure out of nowhere. And when they go to the clinic, normally they'd be told, well, we're going to try this suite of drugs and we'll see what works. And sometimes, often, none of them work. And now we have a handle on something which may actually help, right? These people who have given so much, okay, and yet, if the funding is cut, that's not going to happen. So let's keep an eye on that as well. It's just been Memorial Day weekend, and it was top of my mind. I was thinking, wow, this is the one group of people who really need to be helped and one group of people who can be helped. So let's not lose focus of that.
Well, it's funny because 2 weeks ago, my guest is a former Marine
Oh,
who developed a TBI from his time in service and now has epilepsy. And
Right.
so, and he spoke to, he calls it his blast radius.
yes.
Like, and just how it affects his epilepsy affects him and the people around him. And so, he's not the only veteran I know who's,
Right.
it's a very, unfortunately, it's very common.
Right.
So,
It's actually one of the fastest growing groups of people with epilepsy. They're the veterans who have returned with TBIs.
wow, I did not know that.
Yeah.
Oh my gosh. Well, I want to thank you guys so much for sitting down with me and making the time out of your very busy schedules to do this. But before we end, I'm going to ask you each 3 questions that have nothing to do with what we've been talking about.
Oh dear. Okay.
Everyone gets scared. Don't worry.
His answer is going to be beer.
2 of my answers are going to be beer.
Oh,
And the third is going to be whiskey.
that's one of mine.
Okay, what's your favorite color? Beer?
I don't know if I've got one.
Really?
Yeah.
Is it like because you've got too many, or you just never?
It's just something I've never thought about. But if I now go through and look at all the things I own, where I got to choose a color, I guess it would be a blue type color. Yeah.
Nice.
Yeah.
Okay, see,
Blue.
we're being 5.
Okay.
Picking our favorite colors.
All right.
Yeah. Anne, what about you?
Yellow.
Oh, nice. That makes sense. Very bright.
Love yellow.
Okay.
What's yours?
Light blue and bright red. I can't choose one. I love them both.
You can have 2.
Yeah, one's very like fiery and passionate, and the other's just like calm.
Wait, isn't that Chicago colors?
Oh yes, it is. Okay, I didn't.
I'm looking to the cameraman's colors on his hat right now.
Yeah. So if you guys don't know, my husband Steve, who's a firefighter, is now He's also my cameraman. Hi, babe. Okay. Second question: if time and money were like of no object, and you could go somewhere for a month, where would you go?
I would have to say Europa. It's a moon of Jupiter.
Oh my God. Could you see me just go, what country is that?
Oh, time and money. Yeah, that's where I would go.
Okay.
Because my other life in the evenings at night is I'm an astronomer. And I think whenever I look from my telescope and I'm looking at Jupiter and its 4 big moons, and I look at Europa, I think, wow, one day we're going to send a probe there and it's going to melt through that ice and it's going to go underwater where there's an ocean. We know that. Imagine what it would find. So imagine, not to get pessimistic again, but imagine my concern when NASA's funding is also cut. But you asked a positive question, which is, where would I go for a month? I'd go to Europa.
That is definitely a
Okay, I'm
first.
cracking up. You can't pick a color, but you can pick Europa as your favorite place to go.
Oh, I never thought of it that way.
And what about you? Where would you go?
Okay, I'd split it into 2. And I just came back from Seattle and I spent 2 weeks out there. And I think Seattle is one of the most beautiful cities in the whole wide world. I just
that's awesome.
love it. It's so green and beautiful and mountains. And then the other half would be in Maine.
Oh,
So I'm sticking in the U.S. for a while. But
yeah. I haven't been to either. I've heard both are so gorgeous. And I love that you picked like literal opposite ends of the country.
Well, believe it or not, I used to live in Seattle and my husband lived in Maine. So that's how we dated.
Oh, well, that's adorable. We'll have to do another episode on that.
It's a little sordid. You know, do that.
Transcontinental dating.
Yeah. Okay, and then the last question is, what does it mean to you to be a friend?
I had this conversation with friends just a while back. To me, a good friend is somebody who cares how you are. And an interesting friend is somebody who's interested in what the people around them are doing and thinking and feeling, as compared to somebody who just wants to tell you what interesting things they've done and felt and are seeing. So to me, what it means to be a friend is to be somebody who cares about other people.
I love that. Yeah, that's really beautiful. It's also cool that you were just talking to one of your friends about that. Yeah. Anne, what about you?
That's a loaded question. I would say a good friend is somebody who wants to be with me or talk with me, and vice versa. There's no obligation, there's no guilt, because I haven't talked to you in a while. It's just comes out of sheer desire to be with each other, or if you're cross country, to talk to one another.
I love that. Yeah, the no guilt.
No guilt.
Mm-hmm.
Or no, I'm doing this for some other reason. It's just because you want to.
Right.
What about you?
No one's ever asked me that on
Really?
yeah. So to me it's showing up in both good and bad. And being there for both. And loving you unconditionally during both.
Being within your blast radius.
Yes.
Oh,
And
that's a good
accepting
one.
your blast radius
Wow.
as a part of who you are. Yeah, totally.
I like that.
Yeah. Well, thank you guys. I am just so appreciative. I'm so appreciative of the work you're doing. I'm so appreciative of the work you're doing. Like, you guys are my heroes, and thank you. And anyone listening, there's 2 things you can do. You can donate to Lily's Fund, which the link is in the episode description, or you can download the app 5 Calls. You enter your zip code, and you make a call that takes 5 minutes to let your representative know that we need NIH funding back. Thank you again so much, you guys. This has been an absolute pleasure.
Really, really enjoyed this. Thank you very much.
Thank you, Landis.